In this video, I want to talk about some different C++ syntax and some techniques that you'll see off and on throughout the semester and also in examples you may see in other places. So some of these things we'll come back to later in the semester, but I wanted to at least give you an introduction in case you want to start using these now. So initialization in C++, we can initialize like this, just by assigning a value when we declare the variable, and we've seen that before. We can also use an initialization list, and we saw this something similar with our objects. And we can also do an assignment to an initialization list. Now, one of the advantages of an initialization list, let's say we have D is equal to 3.14, and we have E is equal to 3.14, but we'll put that in an initialization list. Let's compile this and see what happens. And you'll see narrowing conversion of 3.14 from double to int. So I get an error, not just a warning, I get an error. In this case, what's going to happen is it's just going to truncate that variable. But here, I'm not even going to be able to include that code because I get a compiler error due to incompatible types. So that's helpful because it lets me check situations where I may be not sure of the value, the type of what I'm using to initialize a variable with, and I'm losing information in the process. So I'm going to print these values out. I'm not going to print out E because there's no point since I can't declare E. And so you see the values are what you would expect, except perhaps D, which isn't 3.14 anymore, it's just 3. I can also use what are called automatic types. Those are deduced from the initializer. So I could say auto m is equal to 3, auto n is equal to 3.14, auto p is equal to the string hello. And I think I left out O. So auto O is equal to the character X. And I can print those values out as well. And let's compile and run our code to see what happens. So no errors. And you can see each of those was initialized with what we want, and they'll actually hold that type. So this will be a char, this will be a string. A couple of downsides to the advantage of this auto is, number one, some cases the type of a C or a C++ variable could be very long. If you have templated types and so forth, there can be really long names there. So using auto sort of simplifies that. The other is if you're not going to do much with that type and you're not going to be calling methods on it, you're just going to move that object around, then auto is fine in that case. Now, the downside is that you're not specifying what the type is, and so it's not necessarily going to be the type you expect. So this could be a string object, or is it a C style string? There's lots of different types of strings in C. Which type is it? So again, auto is nice for cases where you don't really care about the type. You're not going to do anything specific to the type with a variable, but it does let you and sometimes save a little time with how wordy your code is. In summary, I think auto is nice when the type isn't that important. You just need to get the variable in, and we'll see an example of that later in this code. It's still something that's there more for reducing the amount of typing you have and potentially clearing up how your code looks, making it a little more clear, but you lose that specific type information unless you know exactly what type the literal is that you use to assign it is, or the variable that's used to set that type. Okay, so our next example, we'll see constants. So with constants, there's a new additional way we can declare a constant in C++. There's the old constant variable type, and then there's now a const expression. And the advantage here is that this has to be something that's knowable at compile time. And so it'll get initialized at compile time with its value. And my understanding is that it can be optimized a little better. I'm not sure of the mechanics of that. But if we print these out, you'll see that we get, oops, CASP. So let's do this. And if we print this, you can see my constant and my constant expression. So there's a few minor differences here that do affect how they work. But if you just think of this as the constant expression is something that I know about during compile time, I can know what its value is, and then it can actually be used in other places where you require a compile time constant. So there's also something in C++ called a range for, or a for each loop. So if I initialize a vector of int, and I'll initialize that to 1, 2, 3, 4, then I can say for auto, and then I'm going to get a reference to that, and I'll print each of those values. So when I print it, or when I run this, you'll see that it prints each value in the vector. Now, I probably want to make this a const reference, because I certainly don't want to be changing that in the loop. I'm just printing it out, so I'll make it a const. And yeah, so it behaves the same way, but now if I try to do something like I is equal to 4, it won't let me because I'm trying to read that. Whereas if I didn't do that, now it let me try to change that. So if I come down here and then print it all over again, so what I've done is I'm modifying it there. So when I compile and run this, you'll notice that I'm changing it to 4 each time. So that's not good. We want to avoid that. So typically, if you're just going to be printing things out, use const. In some other examples in this module, you'll see pointers. Just keep in mind that C++ has pointers. If I want to set something to be a pointer to be null, I can use null pointer, which gives me a null pointer. So I can say if pointer equals null pointer, and then I'll print pointer is null. Otherwise, I'll print pointer is not null. There's just a couple things that I think you see some of the syntax that gets added with C++ versus C, and most of these are pretty minor changes, but you should get in the habit of using the pieces from C++ when you're writing C++ code. Even though a lot of your C code will compile and run, that's sort of a legacy thing, and it's best in C++ to try to not rely too heavily on C and only do so when you absolutely need to. So it'd be good for you to learn some of the syntax, and we'll touch on a lot of these later on, especially vectors and the for each loops and pointers.